Hello and welcome. We're live. Welcome to Pactober's workshop number 2, which will be based on Message Pact. So first off, happy Pactober, everyone. We've been celebrating 10 years of Pact, and I hope you managed to catch up with some of the activities in yesterday's Pactober event. If not, you can catch the recap on YouTube at any time. So without further ado, we'll move on with our workshop. So first off, Pactober is being recorded. All the events are being recorded and being live streamed to YouTube. For this particular workshop, you can catch up with the upcoming ones over the course of October via this URL, Pactober/workshop/watch. And after Pactober, these will link to the YouTube playlist where you can catch up with the workshops in your own time. So a couple of bits of housekeeping and things to note. There is a code of conduct that we participate when participating in any activities in our open source community, be it on Slack or in GitHub or on any of our video meetings. So you can check it out on docs.pact.io contributing, and you'll be able to check out more. If you ever have any questions at any time, you can feel free to ask us on Slack. We can reach out the special handle Pactober, or you can just reach out in general in any of the language specific channels. And then also we're after feedback for the event. This is only the second time we've done a large scale community event, and we'd love to make things that resonate for our community. So we'd love that feedback from you guys as to what works and what doesn't work. So we're going to take we'll just have a look at the agenda for today. So we'll take a look at the rise of event-driven architecture. We'll discuss why contracts matter, and we'll take an introduction into the concept of Message Pact, and then we'll do a presentation-based demo of Message Pact based on a SNS provider, but the protocol transport mechanism is largely irrelevant here. And then time dependent, we'll show you a demo, and we'll also show you how you can get involved, but we'll provide you some code links. So when we go through the slides, you'll be able to see the associated code. So we often hear that if we just used insert new tech here, then we wouldn't need contract testing. But is that true? Is REST really the problem? And could we save ourselves the trouble by having to think about contract tests with a superior approach to conversation? So the answer is no. In fact, looking at them, some of them can lead to alternative problems that REST solves. So it might not be a surprise to many for those who watched Seb Rose's opening talk and that heard many of the talks yesterday at Pactoberfest, that there was this discussion around explicit and implicit contracts. And I really liked Seb's analogy with the nuts and bolts. And they also discussed a language called Eiffel, which had this concept of design by contract. So it's not a new paradigm, and I don't think new protocols and mediums of communication are going to solve that kind of semantic meaning of the languages that our systems communicate by. So we're not alone in thinking this. Many people have spoken about it, and there's lots of different material you can find on the internet about it. So here's Matt speaking at API Days in Australia, talking about why schemas are not contracts and why contract testing still matters in the age of ever-increasing protocols such as gRPC, Kafka, and GraphQL. And as well, there's been the rise of serverless computing, which isn't truly serverless because the servers are just on someone else's computer. Or as Saron likes to say, could be on someone else's fridge. So there's a few different interaction type concepts now in Pact to try and cover these types of interactions. So we have the synchronous HTTP. So this was the original Pact interaction. and it represents the synchronous request response mechanism that's executed over HTTP. And it contains a request entity that's got all the HTTP attributes required to construct a HTTP request, and it's an equivalent response entity. And then there's this concept of synchronous and asynchronous message systems. So asynchronous messages might be a one-way interaction between a producer and a consumer, or a synchronous message transaction might represent a request and response model where the transport mechanism is not using HTTP as its transport mechanism. And there's a huge amount of these to list, and it would have been very difficult for Pact to have tried to cover these. So Pact now affords the ability to increase and cover the available transports. So you'll be able to read about those. You can read about those in the V4 specification, but we'll also have a workshop next week where we'll introduce the various plugin capabilities. So the use cases for synchronous HTTP are traditionally REST, which is traditionally over JSON, SOAP, which is XML over HTTP, JSON RPC, and GraphQL. Asynchronous messages might be things like Kafka, fire and forget, server push. And synchronous messages might include use cases such as gRPC or protobus, WebSockets, MQTT, data pipelines, or AWS Lambda. So back in, so we mentioned the Pact specification. So Pact specification V1 and V2 were very much centered around HTTP transports. So in Pact specification V3, a Pact specification V3 was introduced. So there's a source link here to the specification where you can read more about all the features that were introduced. But the biggest one that was important for us in an event-driven architecture was the introduction of messages for services that communicate via event streams and message queues. So I've just added a snippet of the Pact specification on the right. So essentially, for anyone who is very familiar with Pact, when you run a Pact test, it emits a JSON file that contains the expectations. And in that JSON file, the specification was updated to allow for a messages block. If you look at a V3 specification for a HTTP, that's contained in an interaction block. This means that one of the limitations of, hello TM, nice of you to join us. So one of the limitations of this different kind of top level key in our specification of messages for message-based interactions and an interaction top level key for our HTTP-based interactions, it meant that users of Pact that existed in both a HTTP and event-driven ecosystem, which is very, very popular. So teams that may move to microservices may traditionally use HTTP paradigms, but then they may choose to move to things like SNS, Kafka, Kinesis, event streams, and many other transport mechanisms. So there was a limitation whereby on the provider side for verifying these, the consumers needed to be aware that they needed to generate the Pact files with different names. So the providers would have different appended names on them to suggest that one was a message-based system. So obviously this need for this now kind of intrinsic need to know about the Pact specification in order to use both of these paradigms in your Pact tests, in your consumer contract tests, is difficult for users. So Pact specification V4 came along, And again, you can read around in the same place in our Pact specification repo, and you can actually view all the historic historic specifications by going through the branch selector in GitHub. So one of the probably the biggest key change for everyone was these multiple interaction types were contained within a single contract file. So now there's the familiar interaction key that we had before, but there's also I can't think of the particular key at the moment, but a key that defines whether it's a synchronous HTTP or an asynchronous message or synchronous message type. And it also allowed us to extend our interactions to not be fixed by the Message Pact format that we'll look at today and the HTTP format that Pact is designed for, but also to allow not only the maintainers to extend the functionality, but actually the community to extend the functionality at large. So as we've seen Pact rise in adoption, we know that the current maintainer level and generally the maintainer or contributions in open source, they are far surpassed by the users of open source. Now, that's not a bad thing, but we really want to be able to allow people to extend the framework. So in the next workshop, you'll be able to see how the Pact plugin framework will allow us to deal with the multiple transport mechanisms that are involved in these event-driven architectures. So in order to find out more about Message Pact, which is just very specifically based on the content of the systems, the communications between the systems, and is completely agnostic of the transport mechanisms, you can read the docs. So you can just go to docs.pact.io. You can look in the left-hand bar on the Getting Started side. You can check out the How Pact Works section. And at the top of that page, it will show you about HTTP testing. And then lower down, it will show you about Message Pact, so non-HTTP testing. And then if you're further interested, you can read the Pact plugins page, which will allow you to maybe provide you some pre-reading for next week's workshop. And as you go through this Message Pact kind of getting started resources, it will point you to two GitHub repositories where you'll find an example consumer and an example provider. And they might be called in messaging parlance producer, which is analogous to our provider, and a consumer would be a subscriber in messaging parlance. So I'm not sure if I'll just take a brief moment and see if there's any questions, but if not, we will move on to our workshop. So I've got some links for you that we will pop up in the channel. Just put a link in for the Message Pact getting started, and I'll provide one for the two links to our repositories. Hi Priya, lovely to have you here. I know you'll have some questions. I definitely know you mentioned some yesterday. I will actually provide a link because we have a Kafka example that follows this format as well. So these particular examples, they are actually hosted on our the commercial site Pactflow, but the example repos are all open source MIT license, much the same as the Pact Foundation and you can use them completely standalone without using Pactflow. So Pactflow offers a hosted Pact broker, which is just nice and easy for people who don't need to worry about hosting, but we can run the Pact broker locally on our machine using Docker. So whichever is your flavor is all cool. So hopefully you'll be able to pull down the repositories, but if not, we'll be able to, we'll just go through the kind of code snippet, describe the repos, and then you can potentially, if you're following this in the recap on YouTube, you can follow the links that we'll be putting in the comments, and you can follow this offline. And please feel free to just jump into Slack at any time and chat to the team if you have any questions or get stuck. Cool. So how would you go about writing a Message Pact test, or why would you write a Message Pact test? So we mentioned about event-driven architecture. So what kind of is event-driven architecture? So modern distributed architectures, they're increasingly integrated in this decoupled asynchronous fashion. So with a HTTP style response, you have to send a request and you have to deal with some kind of response. So you might be familiar with your status code. So there's always something you're kind of getting back from this HTTP request. But in a message-based system, you might want to publish a message. So an event has happened in your system, and there may be one or multiple subscribers to that message. And depending on your type of event in your system, you might want multiple things to do multiple different responsibilities with that message. So say, for example, in your system, an order has been placed, you might want a ordering system to go and fulfill that. You might want an invoicing system to send something to the customer. You might have an email system that sends out the emails. And the producer of that message, if they're able to publish to an agnostic source, so like an event bus, they're able to decouple themselves from their consumers. This ability to decouple themselves from their consumers means they can build this initial publishing service, and they can just go away and do other important stuff in their business. And when people need this new functionality, they can just subscribe to these messages. Now, we have seen from the talks before that the problems that we have between the communications in systems cannot be replaced by tools like Pact. So they really are no replacement for collaboration and communication. So the messages that we still send between these systems are important, but it's very difficult to try and cover all the multiple protocols and queuing technologies that are available. But the real important part of these systems are the messages that pass between them. So there's so by that point, there'll be potentially some changes that you may need to make to your code. Now, hopefully you may be following some of these principles, and we'll describe some of these principles in a moment. Hexagonal architecture is one of them. So Message Pact itself will not focus on the transport technologies. So it won't test Kafka, it won't test SNS itself, but it will test the messages that are sent between them. So in order to do that, we'll recommend that you split the code that's responsible for handling the specific protocol. So if you're going to send your messages via a Kafka queue, and the application-specific logic. Now, this kind of idea of ports and adapters can allow you to move your systems or evolve your systems in a more decoupled fashion. So, for example, if you need to replace your Kafka queue with another type of queuing mechanism, by having your code split out at this level, not only does it make it easier to test and to generate these Pact contracts, as we'll see, but it also makes it easier for you to evolve and migrate your services. So, for example, you may have really your business might be so critical that you can't hold it on a single cloud provider. So you may need to use several different queuing technologies that are supported by different cloud providers. So we'll take a look at what that looks like in a example today. So we'll look at AWS Lambda handler and its input body, and then we'll look at splitting out the code that handles the message payload and does your business logic, and we'll wrap a Pact test around that. So we mentioned before about hexagonal architecture. So another term for this is called ports and adapters. There's, I believe, Alistair Coburn was one of the pioneers of this. I'd recommend Googling the term and checking out, feasting on some of the content that's out there, because it's a real interesting read. So we've got this idea of our adapters. So our adapters are our potentially our transport mechanisms. So they'll be our kind of queuing technology. So it could be a Lambda handler, it could be a Kinesis queue, and we have this idea of a port. So the port is our ingestion, kind of our way of getting into our service, and our port will abstract away the details of our adapter, and that will allow us to change our adapter or add additional adapters. And this port will serve as an interface into our business logic. So much the way in our when we talk about the way our services are comprised in our HTTP paradigms, we talk about kind of the collaborator service that talks to the external HTTP provider, and then we talk about that interfacing or being the kind of buffer point between that bounded context and our internal application. So by following this pattern, this modular architecture, it will allow you to not only test your code more easily, but also, like you say, evolve your services as your needs change in your business. So our particular scenario today will be focused on a product update API and a product API consumer. And our product API will receive API requests, and when it does, it will publish messages to an SNS topic. This SNS topic will be aptly named the product topic, and the consumer of these messages will subscribe to an SNS topic and read messages off that SNS topic. So it will be really important for that consumer to be able to speak the same language of the messages that product update API is talking. So we want to be able to test that our product update API will be able to generate and produce the valid events that this particular consumer expects. Now, our product update API might publish several fields to this SNS topic, but each consumer may only require singular or only a subset of those fields. So by utilizing Pact here, not only will be able to leverage those same guarantees and visibility into not only which consumers rely on this product update API, but again, which kind of down to the field level and semantics of those field levels, what they require. Feel free, if anyone has any questions, to throw them up in the chat. If they're not necessarily super relevant to this, please feel free to hang on to the end, and I'll make sure we've got some time to ask some questions. So the message, we mentioned before that the message format between these systems is really important, and Message Pact isn't going to be concerned with the transport mechanism. So if we look at a singular test, our consumer would expect to receive a message in a particular shape. So the kind of general scope of this event is an updated event, and then there's some details about a product that is being updated. So with our hexagonal architecture in mind of our adapters, ports, and our business logic, the code base is set up with this modularity in mind. So if you have one of the example consumer repos open, either the SNS or the Kafka one, you'll see there'll be a Lambda handler. So this Lambda handler will be responsible for taking the messages, extracting the messages off a particular queuing mechanism, and reading the particular contents of that message, and then passing those contents on to the actual message handler. So this particular event we saw was an updated event. It may be that this particular handler has logic in it that routes based on the message in that event, depending on the particular update that was requested. It may call a different message handler in order to process that specific message. We then have our event service. So this is our port. So here, this job is to of receive product update here is it's completely unaware that it's talking to SNS or Kafka. Its singular job is to receive this product update and then do something with it. So in this particular function, its job is to update a product. So it hopes to receive a valid product. It will try and marshal that product into a new product object, and then it will insert it into our database. And then if we take a look at some of the business logic that's contained, it's separated. So we've got our product class. So that contains all the particular items in that message that this particular unit of code requires to function. So it's going to need an ID, type, and name. With this being JavaScript, it's not providing huge guarantees here. We'll be able to get an ID, which is a number, and it will convert it into a string. But here's where you provide your particular schema for your domain object in your repository, in your code base. And then here we have a product repository, and this product repository is just an in-memory database representation and has all the mechanisms for our consumer code base to interact with a store of the domain objects, and in this case is a set of products. So this kind of data access layer allows us the ability to get products from our database, insert them, or fetch them. So for the purposes of our example, this is just an in-memory database. You probably have a real database. In your testing, it would be advisable to, especially at the unit testing layer, to allow your code to be able to use a potentially mocked out database in memory in order to provide speed and repeatability. Otherwise, you can potentially just run a copy of your database offline. There's various different mechanisms. If you're worried or confused and not sure how to approach it in your particular use case, again, please feel free to speak to anyone in Slack. As always, with community repositories, use cases on GitHub are fantastic because we can mob around them. Sometimes you don't know how to start with Pact, so just getting that original use case in. So here's my kind of basic Kafka code base. Can we help put Pact in it? That's a lot easier for people, especially in the open source, to jump around. So we've got a Pact test. So in a Pact test, we will need to follow our 3 golden A's. So they are our arrange, act, and assert. So in the first phase, we need to arrange and set up the things that we need for our test. So here we're showing it for JavaScript. It will vary in your particular language, so please check your documentation. So you'll import your Pact library, and then there should be a message consumer class. And in that message consumer class, there will be some kind of message handler, and there'll either be a synchronous or a asynchronous body handler. They're very difficult to distinguish when you say them, but they're definitely 2 different words. So there's a synchronous and an asynchronous body handler. And then we actually have our system under test. So as we said before, we're going to test our received product update, which is completely agnostic of our transport technology. So we are not testing Kafka, we're not testing SNS. This is also brilliant because it means that we can get really quick feedback on the important business logic while not being bound by our transport layer. That's not to say that testing your transport layer is not important, and that's why we'll see that with our plugins next week. So once you've imported your Pact library and the message consumer class, whatever it's called in your particular language, we need to set it up. So you'll be very familiar if you're using HTTP Pact. So every Pact is a relationship between 2 parties. There's a consumer and a provider. So in our messaging parlance, our consumer will be the subscriber of the message, the one that is pulling that message off the queue, and the provider in messaging parlance is our producer. So that is the team or code base that's responsible for putting the message onto the queue. And then there may be various Pact options that are relevant for you in your particular Pact language. And then we need to perform our particular Pact test. So we said before that the Pact tests are unit tests. This is no exception for our Message Pact. So Pact test itself, the Pact framework itself does not provide a testing framework for running your tests. So you would have your own unit test runner, and that would vary between your particular programming language. And depending on your programming language, there's generally multiple test runners. It's difficult to keep examples for every single test runner. So if there's a particular test runner you're stuck with, again, please feel free to build an example and we can build that in. So we mentioned before about the 3 A's. So we've got our arrange, act, and assert. So in our particular test, we're going to set up an expected state. So this is if we're talking in behavior-driven development, we've got a given, when, then scenario. So we've got this given state. So this is set up by our expects to receive here, and this is telling the provider team what type of message they are going to expect it to produce. And for this consumer, the type of message that this test, so we're doing a very scoped unit test, what this particular test expects to receive. And then for this particular product event update, we're going to set up, so we're going to arrange our expectations. So we're going to set up what this message that will be sent to our handler contains. So here, this message should be relevant to the particular needs of the received product update handler. So if it relies on the ID type name. It doesn't rely on other fields, don't include them. So we can also see here, they're wrapped in something called a like method. So these are pact matches. So pact matches allow, when we provide this representation of the expectations in this test to our provider is expected to provide a message that will match this shape. If we don't have these like wrappers around this particular value, some UID, our provider will be expected to provide us an object with the shape ID with the exact value, some UID. Now, that's a very strict mechanism, verification mechanism that this test would enforce on a provider. And the real important thing that we're trying to test when we're going to verify things on the provider is the shape of the message. And our particular receive product update code, it might need to expect certain types of the fields that are being returned. It might need to return specific shapes of objects. So there are different matches in the Pact framework that allow you to provide this loose matching capability on your expectations that you'll bind with your provider. So it'll mean that in this example, a provider will be expected to return a message of the shape that contains an ID type and name, and the like matcher will look at the type of each of these examples, and it will use these examples as a human-friendly way of viewing this contract, but will encode these matches into the verification such that when the provider returns this shape object, they can return any ID as long as it's a string. You can enforce stricter restrictions on each field depending on your business requirements, but you should be very careful here, potentially not to either encode too loose matching rules or too strict matching rules, so you're testing business logic. It can become a very fine line, it's very subjective, and again, contract testing a replacement for collaboration, so usually speak to your provider teams and work out that kind of viable compromise. And then the message here is kind of this with content block contains the real business specific logic. There is often some, so we mentioned before, we're agnostic about the transport layer, but there's still information that may be relevant to that transport layer. And it would be pertinent that the provider provides that. So in our example, we mentioned topics would be published to a provider, we've got an event bus and we've got a topic, and that topic is product. You can have multiple topics published to that event bus. So there might be very different messages for different purposes. So this particular product consumer is only concerned with reading the product messages that exist on that message bus. So there is an ability to capture that, and it's with using, depending, again, might vary with your language, but generally the DSL will be with metadata, and you can contain that. This code snippet is slightly out of date. It's up to date in the repos. If you're following, you won't need to provide the content type of application JSON if the content type you provide is JSON. And then there's a verify block. So in the verify block, we mentioned before about also importing, when you import the Pact library, you import a body handler. So this body handler will take an argument, and that argument will be your event handler. So the job of the Pact framework here is to take the content provided in your expectation, and it will pass it on to your receive product update. Your receive product update is expected to return a valid promise. If that valid promise is returned, this test will pass and a Pact file will be generated. One point to note is we have matches encoded in here. Something that happens behind the scenes, there is a method called refi, I might not be saying it correctly. It's the purpose of taking an example and making it concrete. So that basically means we will take this representation of our body object with these matches, and we'll basically strip all those matches away, and we'll give you a representation of just the this shape object with the values that are contained in these examples. So here, this particular example is a regex matcher. So when we call the refi or rifi method on here, this would give us a JSON object, and the event key would have the value updated. This happens or should happen behind the scenes in your library. Most libraries expose that method, whereby you could set up this as an object you can reuse, and then you can strip the matches off this object and you can reuse them in other tests. That allows you to reshare your test data potentially with your other integration in unit tests that exist. So when you run that particular Pact file, or you run your unit tests, the outputs of our Pact test are a Pact file. So all of those expectations that we set up in the particular Pact DSL that's specific for your particular programming language, essentially all boil down to the same JSON file representation. So here before we spoke about, earlier we spoke about the Pact specification v3, and we have this messages content key. We have a top level key called messages. Within there, we have an array. This array would be if there's multiple Pact tests you've performed for these named consumer and provider. So here we can see all those expectations that we set up in that test. Now, one could potentially manually generate this Pact file, because the Pact specification just sets out what a JSON file, what this JSON file should adhere to in order to be a valid specification file. However, we don't do that. One of the great benefits of using Pact in your unit tests is this Pact file is actually generated as a byproduct of running your tests. And that means that these Pact files that are generated and the expectations within them, they stay in sync with your consumer's code base. So as you'd updated that receive product handler, if that product handler had failed because it was missing a required field, a Pact file wouldn't be generated. So it's really important that you don't generate stale, you don't keep stale Pact files. You'll see in most repos, unless they're used for demonstration, we explicitly ignore them. I mean, you can keep them around, but just be very aware that you definitely don't want to be uploading stale Pact files. You always want them to be an accurate representation of the code at a particular point in time. And once you have that idea of your code at a point in time, whatever's relevant to your teams, we highly recommend Git hashes. But again, it can vary. Once you have an application version to associate with this particular code where you ran this test, you would publish those to the Pact broker, or you can publish them to a Pact broker in order to share them autonomously with your teams. If you're just starting out, it's totally okay to just share them manually. And we highly recommend that when you're on your steps to Pact Nirvana. So I might just stop there and see if we've got any questions for Q&A. Otherwise, we'll go over the provider side. The provider side is a bit easier, I suppose. Cool. So we will get. Looks like we will get 5 minutes for questions, maybe. So again, just remind us on our scenario. We have looked at our consumer. So our consumer set up a Pact test, and in that Pact test generated a Pact file which set out the expectations of the message they expect to receive from this SNS product, SNS topic titled product. So now we need to verify that our product update API can generate that message expected by that particular consumer. So again, we mentioned hexagonal architecture and the modularity that we'll take into mind when setting this up. So this particular service is triggered by an API, a REST API. And when REST API, the code base is very similar to the code base in Workshop 1. So if you're following from Workshop 1, you're more than welcome to try and apply the principles you see in this code base and build on top of that existing example. And then hopefully by the end of the series of these 4 workshops, you can build up a kind of multi-protocol application. So yeah, we've got our REST API, and that's our ingestion point for this service. We've got an event service. So here, this event service will read our events, and then it will publish particular topics. So depending on the event type, which is routed by our API controller, it will perform one of these particular events. So we saw before in our consumer test, we were just dealing with our update, the update message that's being published to that topic. And then we have our, one thing to notice here is this is our adapter. So here, this is aware of the routing, and it's also aware of SNS. So this will actually attempt to publish a topic to SNS. This is not necessarily the scope of our test here, but you can use Pact at this level. You can use things like local stack to mock out SNS and kind of get that richer feedback. Cool, so we've got a product class, and this product class, we've got a domain object. So again, similar, this is the product constructor that we published in the message. So here we've got an ID type, name, and version. And only 2 of these particular fields are mandatory, type and name. And we have a product from JSON, and that will take the fields from this message that was sent in our HTTP request and turn that into a new product. And this will be the scope of our test. This is the function that is responsible for creating the events. So this particular event will take a type of a product, and will take a type, and it will create the specific object that is required to be published to whatever transport mechanism. So in our case, we saw in our event service, it was an SNS producer. Again, by splitting out your event creation from your transport provider, this allows your application to be more testable, but also allows you to change your transport mechanism. So rather than using SNS, you could use Kafka, for example. So in our test, similar to before, we need to set up our test dependencies. So in Pact, there is a message provider Pact, So this is that paradigm in Pact v3. We need to be aware of whether we're verifying message pacts or HTTP pacts. If you are fortunate enough to be in a landscape where you're using languages that support the v4 functionality, you can verify them with a single verifier. There is, if you're not in a point at the moment where you have a language that supports the v4 specification on the provider verifier side, there are native verifiers that you can use on the command line. So check out the Pact Rust repo and the docs page, but if not, jump to Slack, can point you in the right direction. So we have our test tools. So we've got Pact, our message provider Pact, and we also need a system under test. So we need our product event, this create event, which is responsible for generating these messages that we will publish. And then we need to set up our Pact options. So I have had to cut some of this out for brevity. However, there would have been one of these options that set up this provider's name. So this would allow Pact to know which pacts to retrieve from a Pact broker, or you can use a Pact URL. So if you're running these examples locally, they've been set up to verify from a Pact URL or from a Pact broker. So if, and the Pact URL can be a URL from a Pact broker, or it can be a local file. So we spoke before about being able to share the Pact files locally. If you clone down both repos, you can run the Pact tests on your consumer side, which will generate the Pact file, and you can set the Pact URL in your shell. Varies depending on whether you're using Windows or a Unix-based system, and you can just set that to the file path of the consumer test, and then you can run make test or npm test or whatever the test command is in your particular provider code base, and you can run that Pact test and get that really rich local feedback. You can also publish the pacts on the consumer side to the Pact broker, whether it's your hosted one or it's a local one on your machine. And you can use a direct Pact URL, which is where you'd be verifying when a Pact file's change on the consumer side, or you can just generally run the provider test, in which case it will use consumer version selectors to retrieve particular pacts from the Pact broker. But one of the key points is you'll definitely need to set a name in your framework so the verifier function knows which provider to verify. So once you've set up your particular base options, which are very similar to HTTP Pact, we need to map the particular state or the message that we need to verify. So in our consumer test, we had that expects to receive block. And in that expects to receive block, we had a description. So that description, if you look in the Pact files, called state handlers, and here are state handlers called a product event update. So on the provider side, the provider's responsibility is to read that description of the scenario they're expected to set up. So again, using those 3 A's, they need to arrange this scenario. So this is where collaboration is key. You need to be able to name these appropriately, because these names will be picked up that were created on the consumer side. They will be picked up on the provider side. So based on this scenario that you've pre-agreed with the consumer, we said, yeah, we're going to create an event and it'll have these particular details. And again, because we've used matches here, it doesn't matter of the particular values that we're providing here, just that they match the specific rules that are in that test. And then we need to set up something called Message Provider Pact in your particular language, and we set up all these different options. So this means that our Message Provider Pact is now primed, and ready for whichever pacts and the expectations that are contained within them. One point to note compared to HTTP Pact is in HTTP Pact, you would set up your provider locally. It might be that you, depending on your framework, you kind of spin it up in memory, or you might need to run it from the command line as an external process. But you'd be expected to have a URL that's exposed for the HTTP communications between that provider. That URL isn't relevant here because we're just passing messages around. So there's no you're not setting a HTTP URL unlike regular Pact. And then, much like before, we provide our unit test, very similar to your Pact framework. If you're using HTTP verification on the provider side, you perform a unit test. So you'll be using your particular test framework in place in your provider side, and you will initiate the test. In that test, it's pretty simple. You call whatever alias you've called your message provider pact, and you call the verify method on that. That verify method will read in any specific pact content, so whether they're retrieved by URL or from your pact broker, and if they match the specific named provider, it will then look for the specific state handlers that were contained in that pact file. Once it finds those specific state handlers, it will check within message provider pact whether there is a registered state handler, and it should, it will then your handler will be expected to invoke that, create that event, which will be returned to the Pact framework. The Pact framework there, much similar to the HTTP Pact, will look at the expectations, so the content that was set up in the Pact file, and it will compare them to the output of that specific handler that we set up in our Pact provider verification. So this is where those matches will become key, because they will allow for either strictness or flexibility in that verification process. The specific details as to how the subtleties between HTTP Pact and Message Pact work at a kind of maintainer level, we'll look at some of those in our workshop 4, and it's definitely a work in process in being able to share that in a FFI maintainers guide. So I know Priya, I believe you've been working on, was it Pact Elixir? But you've been doing some work with the FFI, so feel free to throw some of those questions. Yeah, so here it's just a static map, but you can invoke that in different ways. So I recently looked at a customer's implementation, and they were invoking that through their invoking it a different way, where really we weren't just setting up like static data in regards to who writes the contract test on the provider side. So on this side, I think it'd be the responsibility of the providing team, so the people who are responsible for this code base, but it'd be worked in collaboration with the consumer. So as the consumer is building out their functionality to create an event or to do something with this event topic, they might be having a conversation, talking about their particular business need for consuming this particular event. Don't know if there's any, I think there's definitely work here between sharing that responsibility and sharing the visibility of these states. Because when I've worked in organizations, we there's all these implicit kind of expectations in code bases to try and make things run quickly, right? So in Pact, we mocked out these providers, so we made things run quick, but then we weren't able to share those expectations, so they drifted from reality. And we kind of shared this response multiple times. Different people were using test data or generating test data on both sides of the feed, on both sides, and the teams were all working together on the same product, so they needed this shared notion of test data. So there was a couple of ways we did that. We had an idea of a test data service, which was able to generate data more generally in kind of integration environments, and then the general data that was generated from that, we were in a TypeScript place, so everything was all typed, and we used the same interfaces for generating our kind of production code. And the objects that were generated in our production code, they were the same mechanisms we were using to generate our test code. So we were forced to keep the test code. The test data service was always kept up to date, because it would fail. There was actually a good reason for putting probably pact tests in there to hold those expectations. Cool. So that's really it for now Q&A. So we've got, don't mind holding on for a bit. So TN, I think we might be a little bit delayed on the questions, but I'll hold out and see if Priya or TN have any more. Well, if not, whilst I'm just waiting to see if we've got any questions, I do definitely want to prove that this works on my machine. So I'm just going to delete, I've got pact tests that we created earlier, but we said before we're going to delete them so they don't exist. So I'll run this pact test. So on this side, we've got our consumer, it's a little bit bigger. So we said before that we would import our Pact library and our service under test, so our receive product update. We set up our particular Pact library, so we've got our Pact message consumer constructor, and we then set up our message Pact test on the consumer side. When we run that particular Pact test, so here we run npm run Pact test, it generated a Pact file, which was visible here. You can see it in the Pacts folder, but the location is variable depending on how you set up your Pact files. And then we mentioned before that you can use the Pact URL variable, and you can set it to the Pact file on the consumer side. So if you were just manually sharing it, you might have downloaded it. So you can set that environment variable in your shell. We're just looking at the provider code base here. So if we just take a look at our provider test, we mentioned those base options where we hook up our message providers with our state handlers. So this code base has actually been updated with the Pact roster core, so it's slightly out of date from our slides. I just didn't get around to updating them in time. So here there's a provider with metadata function, which allows us to map those additional fields. So we have that topics product, which is the kind of Kafka related metadata, and then, or SNS related metadata here. And then we have our particular event that we're creating. And if we run that test, if the demo gods are with me, this should all pass. And it didn't, I think it might be malformed. Yeah, I think there's an issue with one of the options here for over. Right. So as I've we'll worry about that at another time. Right, cool. The code bases are available for you to come and check out. You can, if you have any issues running them, please feel free to raise them. I will update this option. So what there are a few differences when migrating from the Ruby to Rust core in your particular languages. There should be upgrade guides or change logs in each of your particular languages. I will share in a particular issue in each of the repos the particular delta for the migration. So for each of these code bases that are prepared today, we upgraded them from Pact.js v9, which was using the Ruby core, to Pact v12, which is using the Rust core. So the pull request deltas will be quite nice to be able to just see if potentially you're using the older Pact.js version and you want to migrate to the later, what it kind of looks like in a more basic example. So thank you very much. And Tien, I can't wait to hear about what you've been up to in your approaches. And if anyone wants to hear more from Tien, he's a regular in our maintainer meets, which you can catch up with. Thank you everyone for attending. I really appreciated Tien, Priya, and our lovely Joe Lang in the background, who's been manning the chat. So thank you very much. If you want to tune in next week at the same time, I believe I'll be running through the Pact plugins framework and showing you where you can play with some demos of them yourself. So thank you very much, everyone. Enjoy the rest of your day.